shrink that down a bit. So most of this is material that Brigitte already covered, about basically describing what the what desktop on demand is. It's a service that provides an interactive environment for submitting programs to Slurm without a typical shell script. And the graphical interface that you use to input Slurm parameters, or the parameters that Slurm needs to schedule the job, that graphical interface is provided by GFX Launcher, which was developed in-house at Lunarc by our department head. So for Python, we have both Spider and Jupyter available on demand here. We have Jupyter Notebook is also available, but it's being phased out in favor of Jupyter Labs. So I'm only going to demonstrate these two. There's also on demand available at Dardel right now, but they only have 30 ThinLink licenses for the entire facility. And in our experience, you can only get on about half of the time. And even if you can, most of the time, the queues are really, really long. So at least for Dardel, for now, we advise using SSH with X forwarding instead. But there are talks ongoing to expand the number of licenses. So hopefully this will be available on Dardel soon. And as Brigitte said, it will also be available on HPC2N soon. And it's most appropriate for interactive work for small to medium amounts of computing resources. It's still preferable to use batch jobs for really large jobs that require, several days of computing. For these applications, for most of these applications, the time limit for starting one of these jobs, or at least the GUI part of it, the time limit is about 2 days. If you run on a CPU node, you might get something like 5 days. So that's the wall time limits node here. So I'm just going to go ahead and skip to a demonstration. So you will find the applications up here in this applications menu. Sorry, the type is a little bit small here. Normally it allows me to adjust the display settings to magnify these, but for some reason that's not coming up right now. So if you want to go to the Python modules, I'll start with Spider, because that's my personal favorite. So you go to Python, or applications-Python, and then you go up here to this Anaconda 3 Spider. And then you just click, and it pulls up this little pop-up. This pop-up is the GFX Launcher interface. Now, as long as I have this applications menu open, please be aware that the only applications that are on-demand applications are these that are prefixed with applications-. So you might be tempted to use this terminal here in favorites. This terminal runs on the login node. So don't do anything intensive there, and certainly don't run any interactive jobs from here unless you use the SL command. If you have to start something from an interactive terminal, you want to go to these applications general, and then either choose the CPU terminal from this, or if you want to do visualization work, you might go to this applications-visualization and go to graphics terminal. Or if you have a GPU reservation, and only if you have a GPU reservation, you can also go to these GPU terminals in applications.general or -general. And if you happen to prefer coding in VS Code, that is under development. So there is a Visual Studio Code there are a couple of versions of Visual Studio Code under applications-development. And these do allow Python programming with like a JupyterLab extension, for example. But anyway, back to Spider. So I've popped up this little, as you can see, I've popped up this little GUI here. That is the GFX launcher. Here you can set the wall time. That's the amount of time that the GUI runs. If you launch something that is a batch job from any of these on-demand applications, any jobs that go to Slurm are bound by separate parameters. So this wall time restriction only applies to the GUI itself and any jobs that are run interactively within it. Then this requirements box lets you set the number of tasks per node, and if you click this little gear icon, you get extra options. So here you can specify the job name if you want to. You can increase the number of tasks per node. I'm not actually going to do that. You can also request an entire node, and that will get rid of these two options. You can also, by selecting memory, the default value here is the amount of memory per core, assuming the memory is evenly distributed among all cores. You can actually request more memory for a single core, but what you're doing is taking memory from a separate core and shuffling it into the core that you're on. And that means you're actually going to be billed for however many cores worth of memory that you shuffled into that single core. I see some. So then you can also use a reservation, like for instance, for today, it would be Python for HPC day 2. I could start, and I'm not going to select memory because I'm just going to use the default value. Then I click OK, and then I click the project for this, the project that this reservation is under. And then after that, I can just click Start. And if there are any issues with the start, you can click More and go to Log and see what is, and see if it raises any error messages. But I don't think we'll get that here. So I'm going to click Start. Oh, okay. So I must not have the correct combination of parameters here. So I'm not a student. So I will use a different account. So I will just click Start here. And if it's starting, you'll get this little green box. So then in Spider, you get this nice little interface where you've got a code block over here, an IPython terminal in the bottom right, and then the top right lets you, the top right makes plots visible, but I prefer to pop this out as a separate GUI. But I'm not going to go into that right this moment because I also have to demonstrate JupyterLab. But what I can do is I can just go ahead and run this little demo code that's already open from a previous session, and that will show you. So this is a GUI that I had already made, or that I set up the code for already. And this is what the GUI looks like when you set it up to pop out a separate GUI for the plots. And here you can make some changes to the formatting or the change the margins, things like that. So I'm going to close that and close this. And usually once you close the application, this little green box goes back to gray, and that means that your job is no longer being run. Now, if you get to the end of the wall time and your application is still open, it will close immediately. So you need to save frequently and keep an eye on this little usage bar here, because the usage bar down here tells you what percentage of the wall time you've already used. And when it gets to 99%, it's about to shut down. Also, once you have a GUI session open, you need to keep this little box here open the entire time, not just to monitor your jobs, but because if you do close this window, whatever application it was running will also close immediately. So I'm showing Jupyter Lab because it has one extra little setting here, this job settings box. And what you can do here is that you can either choose additional modules, or, and this is what's most useful here, is to use a custom Conda environment. And so this is something that you might use if you have like TensorFlow or PyTorch, which usually require special environments to be loaded if they're installed locally. So I am going to select this T-Flow, and that was built to be compatible with Anaconda 3. Be warned, if you select other modules, when you search for something, the previously loaded module goes away, at least if you select it. And you need to make sure that this Anaconda 3 is still there, because Jupyter Lab depends on Anaconda 3. And without that, it will not start. So anyway, I've selected all of that. So just click OK. The settings here are the same as before. Usually for these things, apart from the wall time, the default settings for resource specifications, as long as you're doing light jobs, they're usually fine. The default settings are chosen to work well with the program in question. So I'm going to start this. And then Jupyter Lab should pop up in my browser any second now. And there it goes. So now I have some demo code open, something like that. And it prints just fine. And since this is a TensorFlow environment, I'm going to try importing TensorFlow. Or sorry, this was, did I choose TensorFlow or did I choose PyTorch? Let me go back to the, oops.
It was TensorFlow.
Yes. Job settings. Yeah. Okay, so that's not actually what I meant to click. So let me close this. I don't care about what I just saved. Where did it go? All right. Now, sometimes this doesn't stop immediately. That's okay. You can click stop if you need to. For Jupyter Lab, this typically, okay, so I'm going to close that. And I'm going to go back to settings, and I'm going to click PyTorch because that's what I actually wanted to demonstrate. So, okay, let's start again. And you'll see the usage start to, once this is open and loaded, you'll start seeing this, you'll start seeing the usage bar creep up. So now I'm going to try importing Torch as PT, and it works. If I had not used the PyTorch environment, that would not have worked. And I just used like maybe a minute or so for that, so usage is already 2% now. Now I want to show you what happens if I accidentally close this. So I've closed that, and now now I have a server connection error because the Jupyter Lab has been summarily quit without properly saving or anything. I'm going to dismiss that and close that. leave page. All right. So we've already gone over these settings. If you want to see what the Slurm script is doing when you actually configure all these settings and click start, you can go to script, and this could help you if you want to, if you're doing a job where you're doing it interactively to test it, but you eventually want to run some of these settings as a batch job. Then you can go here to script and see what some of the settings are that you can potentially use to export to your own work. So more, here's the script. Going to enlarge that. So here the setting might be this one. So now the changing the project changes this line, sbatch -A equals this account. The partition is still LU48. That means we're on an AMD 48 core node. Output is just created in this generic output file. There's only one node being used, only one task per node. That would change if I bump that up to, say, 4. Then if I click away, then now it says in task per node equals 4. Then the time is 30 minutes. Now it's 2 hours. This is just specifying the name of the job, and then this echoes a few of the things that are printed out in the log. That's what some of these messages are. They're the echo statements. Print that out. Okay. So let me see. I think we've covered pretty much everything, and I know there was a couple of questions in the chat, but it looks like all of those were from before my session. So do we have any questions now? Yes, I see.